Okay everyone, let's look at Module 26209-23, Grounding and Bonding in the NCCER 11th edition. This will be Section 1.00, Grounding Requirements. Grounding and Bonding. Grounding systems provide a path for misdirected current. Grounding a circuit improves the overall operation of the electrical system. Grounding conductors are conductors that are intentionally grounded. Bonding is done to ensure that all connected electrical components have the same electrical potential. Electrical systems are grounded to limit line voltage to ground during normal operation, stabilize voltage to ground during normal operation, and to prevent excessive voltages during surges. NEC Article 250 is the primary governing article for the proper application of grounding and bonding. NEC Section 250.4A5 outlines the requirements for a circuit's path to ground. Connections made in the ground path must be in accordance with NEC Section 250.8. The grounding electrode conductor, equipment bonding jumper, and the equipment grounding conductor must be adequately sized to ensure there is sufficient capacity to protect the system. Short circuit and ground fault. A short circuit is a conducting connection between any of the conductors of an electrical system. A ground fault is an unintentional conducting connection between an ungrounded conductor and grounded, normally non-current carrying conductor or other path to earth. Grounds and short circuits usually result from a failure of insulation resistance. Types of grounding systems. System grounding and bonding relates to the service interest equipment and its related components. The equipment grounding conductor is the conductive path used to connect the non-current carrying metal parts of the equipment, raceways, and other enclosures to the system grounding conductor, the grounding electrode conductor, or both. NEC Sections 250.20 and 250.21 provide specific grounding requirements for AC systems. Grounding single-phase systems. Here we can examine a single-phase residential grounding system. We see the insulator, the 7200 volt primary conductor, solidly grounded neutral from 7200 volt source, NEC Section 250.184. Splices, the 7200 to 240 120 volt transformer, transforming case, grounding tab, insulator, 120 to 240 volt secondary, splice, and the ground wire. The ground wire runs down to the bottom of the pole and is connected to the ground rod, ground ring, or ground plate. The ground wire is usually run exposed on the side of the pole and secured at close intervals. Service entrance conductors are routed between the meter housing and the main service switch or panel board. Most systems are grounded at the neutral bus in the main panel board. Warning: exercise extreme caution when disconnecting a grounding electrode conductor. Never touch a disconnected grounding electrode conductor and anything grounded, including the grounding electrode, at the same time. Should a fault current occur, your body will become a conductor for the current. This result could be fatal. Grounding systems less than 50 volts. NEC Article 250.20A requires the grounding of systems less than 50 volts in the following situations. If it is supplied by a transformer with a primary voltage exceeding 150 volts to ground, if it is supplied by transformers that are ungrounded, or if it is for overhead conductors outside of the building. NEC Article 250.20B requires AC systems of 50 volts to 1000 volts supplying power to premise wiring systems to be grounded under the following conditions. If the system can be grounded such that the maximum voltage to ground on the ungrounded conductor does not exceed 150 volts. If the system is three-phase, four-wire Y-connected and the neutral is used as a circuit conductor. If the system is three-phase, four-wire delta connected and the midpoint of one-phase winding is used as a circuit conductor. Grounding systems over 1000 volts. NEC Article 250 Part X discusses the grounding requirements for systems over 1000 volts. AC systems over 1000 volts must be grounded if they supply mobile or portable equipment. Other AC systems over 1000 volts are permitted but not required to be grounded. Circuits that cannot be grounded. The following circuits shall not be grounded. Circuits for crane that operate over combustible fibers in Class 3 locations. For healthcare facilities, isolated power circuits in hazardous locations. For circuits for electrolytic cells. Secondary circuits of lighting systems. Secondary circuits of swimming pool lighting systems. Some trade terms we should read over and become familiar with for this module. and some review questions. Suppose a loose connection has an exposed bare conductor that contacts the edge of a metal enclosure. Is this an example of a short circuit or a ground fault? It's a ground fault. A single-phase system has two legs, leg A and leg B. If leg A is carrying 50 amps and leg B is carrying 45 amps, the current carried by the neutral should be, well, the unbalanced portion should be 5 amps. All right, everyone, that's it for that section. The next section will be 2.00 service grounding methods, and I will see you over there.